Hi guys, I thought before we start the two-stage method and big M method, we would have a look at some minimising problems. I apologise, I have hiccups, so you may hear that as I go through the video. Right, so here we have a minimising problem. Now at the moment we've only done maximising problems, but it's actually a really quick fix. So what we're going to do is instead we're going to maximise Q, where Q is negative P. So Q is going to be negative P. Oops, sorry, I'm shaking as well because I've got hiccups. So we're going to maximise Q negative 3x plus y. So we've negated the objective function, so we are maximising the negative of it instead. Now the constraints are the same, but I just need to remember to add my slack variables. I am sorry for these hiccups. I've been waiting for them to go, but they haven't. So we have a slightly different objective function here. It doesn't affect the constraints. So what I'm going to do is put this into a Simplex tableau and use the algorithm as normal. It's a very nice basic one. It's actually in the textbook, but there's not many minimising ones, I'm afraid, so I'm limited to what I can use. So the basic variables are R and S, and I'm using Q instead. And the equations were 2x plus y plus an R, no S, value 12, 1x, 4y, no R, 1s, equal to 8. And then if I rearrange this, it's going to be Q plus 3x, take y equals 0. And I'm just going to put that into my row down here, minus 1, 0, 0, 0. And we can see we've got a negative in the objective function row. So y is our pivot column. I'm going to work out my theta. 12 divided by 1, sorry, and 8 divided by 4. So smallest one tells me that this is my my pivot row, and this is my pivot element. So on my next tableau, what I'm going to do is divide through by 4. And that will make sure the y here becomes 1, and then I will make these go to 0. Okay, so we've got our pivot element, and what I'm going to do, because y is replacing s, I'll change that to a y. That's an R, that's still Q. And I'm going to do row 2 divided by 4. Gives me a quarter, 1, 0, a quarter, and 2. Now to get this to be 0, I'm just going to take away row 2. This cannot make for a great video, I'm sorry, but I've got no other time to do it. So row 1, take away row 2, that will give me 0. Here I'm doing 2, take away a quarter, so I get 7/4. I'll fill in the others and then you can check, because I want to try and talk as less as possible so that I'm not annoying you with my hiccups. And then this one down here, I've got minus 1. I'm going to have to add 1 to make that go to 0. So I'm going to do row 3 plus row 2. 13/4, 0, 0, a quarter, 2. Now we can stop here because we've got no negatives in here. So we've got our optimal solution. So that's a nice easy one. So we've got our optimal solution. We're going to have a value of R and a value of Y. X and S are not in the basic variable column, so they're going to be 0. So here's our solution. For the maximum problem, this is what we've got. Q comes out to be 2, X was 0 and S was 0, Y was 2 and R is 10. But we need to just adapt that slightly for our minimum problem. So remember, Q was negative P. So if our answers come out as 2, that means that our P value is actually minus 2. And these don't actually change at all. Okay, so the only thing you need to change right at the end is your value of the objective function. You have to negate it. Everything else is the same. So I found a couple of questions for you to try. There's only 2 of them. So page 195, there's 2 questions. They are pretty big. I don't know how many tableau you'll need, but there's a lot of variables in there. Okay, have a go. Remember to change it into a maximising problem by negating the objective function initially. Tableau as normal, and then right at the end, once you've got your value of Q out, you need to negate it to make it your original P. Okay, best of luck. Apologies again for me hiccuping all the way through that.